So let's talk about how to quantify charge by looking at the electron. When we look at one individual electron, it holds a fundamental or elementary charge of QE or E, which is negative 1.602 times 10 to the negative 19 coulombs. So if we're transferring a bunch of electrons, the charge involved is going to be some integer number, n electrons, multiplied by the elementary charge. So as you can see here, the total charge, capital Q, is going to be equal to the number of electrons times the fundamental charge of each electron. So do we have to worry about this at all? We just want to go through a comparison between the classical and quantum worlds. So in the classical world, we study E&M phenomena when relevant length scales and field strengths are large enough that quantum mechanical effects can be ignored. So these magnitudes are usually 13 orders larger than the fundamental charge, making it really negligible. But if we do want to study quantum electronics and E&M phenomena down at that scale, then we would have to take the fundamental charge into account. So on the topic of quantifying information, let's take a look at Benjamin Franklin's observations, which were not mathematical, but rather very descriptive in nature. Through his many groundbreaking experiments, he demonstrated several key concepts. So the first one, like charges repel and opposites attract. So basically two positive charges would repel and one of each positive and negative charge will be attracted to one another. He also discovered that the more charges that are present, the larger the magnitude of the force. Number three, when the charged object moved closer, the magnitude of the force increased as well. Finally, number four, he discovered that some materials conduct charges while others do not, introducing the idea of conductors and insulators, essentially. So the conductors are materials where electrons are weakly bound to the atom, while insulators have electrons that are tightly bound to the atom. Now the true question lies in how we can measure such forces. And that's where Charles Augustin de Coulomb came in with Coulomb's law.